Okay, now we are discussing about critical angle and diamond. We have already discussed what is critical angle. I hope you know what is critical angle. If I need to make you revise what is critical angle, let's take a medium. Let's say medium. I hope you know medium by now. Okay, let's say this is my medium. This is my denser medium. Okay, denser medium. May it be air, no, may it be water or glass, anything. Okay, this is my denser medium. If a light rays comes like this, then we already know that it will get refracted, it will get bended like this. Okay, let's say this is my normal, and if I take the more angle and if I try to do like this, then it will go straight like this angle of refraction, this angle will become 90 degree. When this angle becomes 90 degree, this angle, the incident angle, this angle theta is called critical angle. That's the idea about critical angle. Now we want to talk about glass. Let's say glass. Let's take a glass. Okay, let me rough this because it is not that of importance to you. We have already discussed. Now let's talk about glass. What is the refractive index of glass? Glass refractive index of glass, let me represent by this one, is equal to how much? It's 1.52. Okay, this is for glass refractive index. Now critical angle will be equal to how much? Just in the previous video we have derived something. We have derived, or if I need to derive, okay, we know refractive index. Refractive index is given by, okay, refractive index of glass we need to talk about with respect to air, right? So sine of theta a divided by sine of theta z. Okay, this is what we are talking about. Now we are talking about critical angle. Okay, critical angle. So we are talking about critical angle. So what will be critical angle? So critical angle, sine of theta z, angle sine of theta z, let me just call it as sine of c, because this angle, the incident angle, is my sine c. Sine of theta a, refraction angle, it will be sine of 90 degree. We have discussed, actually we have discussed in the previous video. I have already discussed about this. This one will come here. I hope you understood this. This one goes here, this sigma will come down here, and as it is. So sine c, sine of critical angle, will be equal to sine 90 is 1 divided by sigma. Okay, this is my, no, this is actually not sigma, this is eta. Okay, this is eta. I hope it is eta. So 1 by eta, 1 by refractive index. So 1 divided by, this value is 1.52. So I got critical angle to be approximately, if I use calculator, I think I have to take the help of calculator. I will find out the angle to be around this value. I can write down as sine of 41.1 degree. Okay, we have to use calculator for this. This is the least asked question, least important. This is not much important. Till now, Manipur board, they don't much focus on asking this one. Okay, till now I didn't find much of the question asked about this topic. So this is my critical angle of glass. This is critical angle of glass. Critical angle of glass. Okay, now if the angle of incidence is more than this one, then there will be, if angle of incidence is greater than 41.1 degree, then total internal reflection will be there. Total internal reflection will occur. Total internal reflection will occur. Okay, so that's the thing. Now let me take one more page and let us discuss more. Let us discuss more about diamond. Let's say diamond. What is the case of diamond? Diamond, what is the refractive index of diamond? Diamond refractive index is equal to 2.42. So sine of C will be equal to 1 by 2.42. What will be this value? It will be 0.4132, which is sine of 24.4 degree. You have to use calculator for this. I'm sorry, but you have to use calculator for this. Okay, mostly board exam, they don't ask, they haven't asked till now. Okay, since 1990, I think 1992, 93. Since then till now, they haven't asked much of the question from here. This numerical and all, they don't ask, but I'm just writing it down so that it is there in the syllabus. So I'm writing C value will be equal to 24.4 degree. This is a critical angle in case of diamond. Now just observe, in case of air, critical angle is how much? In case of air, critical angle is 41.1 degree. In case of diamond, critical angle is 24.4 degree. Okay, so it is quite less. Okay, so critical angle is quite less. Because critical angle is quite less, total internal reflection occurs more. Are you getting the point? Critical angle is very less, so total internal reflection occurs very fast. Okay, so because of this diamond shines forever, because the light will get reflected inside always. Okay, if you look here in the diagram properly, critical angle is very small. More than critical angle, if I take, like, this is my normal, I've drawn a normal here. Let's say my ray of light is coming like this. Let's say one ray of light comes here, this is my critical angle. Now if a ray of light comes little bit more than the critical angle, you can see a ray of light coming from outside, it will get refracted, bended like this, and you get reflection. Now this ray of light, let's say this is, there is normal here, this is more than critical angle, then it will offer reflection again, so it will keep reflecting inside. Once a ray of light enter inside, it will keep reflecting inside, total internal reflection will keep happening inside. Okay, the light will never escape outside. Because of this, the diamond shines forever. Are you getting the point? Why diamond shines? What is the reason behind the shining of diamond? It is total internal reflection. Why? Because the critical angle is very less. Okay, so can I write down? Since let me just conclude. When the since critical angle is very less, critical angle of diamond is very low or is very less, very small, small will be better, I think. Okay, so when a ray of light, when a ray of light when a ray of light enters diamond, okay, it suffers total, it suffers a number of internal reflection. Okay, inside diamond. Are you getting the point? Okay, so because of this, okay, so that's why this is the reason. Okay, total internal reflection keeps occurring inside. This is the reason behind, this is the reason behind brightness of diamond. Brightness, GHTNES, brightness of diamond. This is the reason why diamond shines. Once the light enter inside, where is my diagram gone? Oh, it's this side, right? This is, let me take this one. Okay, this is the diamond case. Once the light enter inside the diamond, it will keep reflecting inside. This light will keep reflecting inside like this. Okay, it will hardly comes out. Because of this, it seems like diamond is shining forever. Okay, I hope you understand why it is, because the critical angle is very low in this case. Got the point? I hope you understood this.